Good afternoon, everybody. My name is Kyle Salibi, and it's an honor getting to speak with you today. I'm here representing Dr. Kerf's research team, which is part of the Precision Manufacturing Research Consortium at Georgia Tech. Mr. Woods, thank you very much for giving us a little bit of time. I really appreciate getting a chance to talk with you and tell you a little bit about what we do. So I have the privilege of standing in front of a team of incredible engineers. We have a very, very unique situation here at Georgia Tech. We're a research team, but we develop and deploy cutting-edge technology while training America's workforce to use these new digital manufacturing tools. Right now, I'm standing in the Advanced Manufacturing Pilot Facility sponsored by Delta. As you can see behind me, we are fortunate to have one of only a handful of Mazak hybrid vertical machining centers. I think this is actually machine serial number 2, if I'm not mistaken. We have a range of other amazing machines here, but also especially like to point out and thank Mr. Jenka. We're really excited to have this machine, and we can't wait to really get into the thick of working with it. As you are aware, the U.S. is falling behind in its advanced manufacturing operations. We have an incredible base, an incredible workforce, but other companies are outpacing us, and we really need to catch up. Our research team here directly supports the reversal of this process on 3 fronts. So today, we're going to talk about 3 topics. First, how we integrate a plethora of digital manufacturing technologies under a common communication data architecture. This will advance the U.S. competitive edge in efficient manufacturing. Second, we're going to talk about developing and deploying IoT devices that we can use on any machine of any age. This will help to monitor the machines, to understand what goes in and out of the machines, and optimize them for efficiency. Finally, we're going to talk about how we develop our educational curriculum to train the next generation of manufacturing leaders. To do this, I'm going to introduce 2 of my colleagues. They're some of my closest friends on this team, Daniel Newman and Eddie Wynn. And we're going to broadcast to you from 2 different locations on Georgia Tech campus. First, of course, right here in the AMPF, our Advanced Manufacturing Pilot Facility, and also from 2110 Classroom, which is where our students are training on manufacturing methods. So, the Idea Lab in part was sponsored by Autodesk, and I'd also like to thank them before we go any further. We hope all the Autodesk folks in the room, hope you guys will enjoy how we've been using Fusion 360 and integrating it into our curriculum. So let's get started. We develop technology from all aspects of digital manufacturing, especially as it's applied to CNC machining. For example, some of our former grad students, such as Dr. Tommy Tucker, have developed SculptPrint, which is a voxel-based CAM modeling system. As you can see from this propeller right here, we can precisely predict the exact surface finish and marks that are made from a 5-axis machining process. Just as another fun part, we've made a Kong head and other complex parts to show the benefits of this capability. We also develop IoT devices for monitoring machines of any age, and we'll get to that later. We're creating retrofit kits to upgrade old technology or legacy machines. For example, we have a 1986 Morisiki machine sitting in the corner over there that we've taken all the electronics off of and are retrofitting it with a brand new controller. And finally, we have data analytics for creating a digital twin model in partnership with Boeing to intelligently predict the parts that can come out subpar. To accomplish all this, we've created a common data architecture, and that's going to be the main point right here. There are 4 things that go into this data architecture. First is the machine tool. Just like you see the Mazak behind me, most modern machine tools communicate via a standard called MTConnect. I think you guys may have heard of it before, actually. But MTConnect is implemented a little bit differently on every machine. So it changes just slightly from machine to machine and from manufacturer to manufacturer. To take that MTConnect data and aggregate it into a common format, we have a gateway. That gateway takes all the data coming out of it, collects it, and streams it out in a common format based on JSON data packages. Now that data goes to the 3rd part of our process, which is the Mazak Smart Box. Security is a very big concern right now, and the Mazak Smart Box helps by separating the networks. Each of the networks are completely separate from each other such that data can flow out but not come back in. We're very fortunate to partner with Mazak and get to use their incredible equipment. We've actually taken the Smart Box that you see right here, developed some new wireless capability and expanded its capability, created the Smart Box 2.0, or affectionately termed the Smarter Box, and we've given these designs back to Mazak to help them improve their own products. Now the fourth and final thing is the message broker. This resides in the cloud. You know, the message broker we use on AWS web services, and it acts as a traffic cop. It takes all the messages that are sent from all these different machines, aggregates them, and sends them back out to the right places. Now, this is a very, very hand-wavy explanation of what our data architecture is. So, we'd like to show you a desktop implementation of it. We've taken this architecture, now we use cloud services, but this can be taken anywhere and deployed on any machine in a closed-off environment without the use of cloud services, and also without the use of any type of wireless communication. So we've developed this architecture and implemented it on a desktop machine. I'm going to turn it over to Daniel Newman, who is one of our grad students as well, and like I said, one of my close friends on this team. He's going to talk to you a little bit about this PocketNC Connect, which is the second topic that we have today, and how we've implemented this on a desktop architecture. Thank you very much.
Thank you, Kyle. So to demonstrate the technical architecture that Kyle's been describing, we built what we like to call the PocketNC Connect. This tabletop demonstration that we've developed can be used to demonstrate the architecture that we've been describing, as well as be taken anywhere remotely without any reliance on any external network, and we can demonstrate in a closed loop exactly how the data from our machine flows to the message broker, which in this case is a low power Raspberry Pi, to the MQTT broker, and can be streamed in real time to monitor and optimize these machines.
I'm in the ME2110's home base, the Idea Lab. Thanks especially to Autodesk for their generosity in supporting this lab with the tools and resources. Today I'm going to talk a little bit about how we're using Autodesk Fusion 360, the MCO E350 mill with the Siemens 828D controller to train the next generation of digital manufacturing leaders. The ME2110 class is a sophomore level build, design, create course, and we take in about 300 students every semester. In fact, Georgia Tech produces the largest percentage of mechanical engineers in the US every year. Now, why is that important? The US is falling dramatically behind in digital manufacturing innovation and capability. So our goal is to engage and excite students about STEM and manufacturing. We're using the class as our vehicle. That class, the main point of that is to students to design and manufacture machines. These machines need to accomplish a certain set of tasks, and at the end of the semester there's this big competition. This year it's Harry Potter themed, so we get a little extra magic. The students are also supplied with Mechatronics Kits. These kits have microcontrollers and actuators and motors and sensors, including this pneumatic actuator hinge. We want to use CAM and CNC to show them how to think about manufacturing when they're designing to make robust parts and designs like this hinge for the pneumatic actuator. So, how are we going to do that? Let me break this into three parts. First, we're going to teach students how to use manual mills and manual lathes, basic machine tools. It gets them familiar with how they work, what they can and what they can't do. We let them use plastic first, so they don't break too many things anyway. After that, we graduate them into the CNC world. We're using the MCO E350. It's a small but powerful package. It has full CNC capabilities, and with the Siemens 828D controller, it lets them go through what a regular quote-unquote workflow would be in the real world. The Siemens 828D is super powerful. It can talk to Autodesk Fusion 360 almost one-to-one. There's very little post-processing that needs to be done. So we can use that to our advantage. Fusion 360 has inbuilt CAM, CNC simulation tools. And the third part is that we're teaching students to generate those tool pads to make the G code, to make the CNC run and produce those parts. Now, once we actually do that, we're actually going to have the students make these hinge mounts out of aluminum. And today, I'm going to be making that. I'll be running the machine to make another one of these. I've already started it. It takes a little bit of time, but I'm going to run it as if the students are actually making this. They will run the CNCs on their own. They get some time with the MCO. They're trained on it. They learn how to use the tools. So I'm going to run it as if I'm a student. This simulation on the screen over here is exactly what they do. They program the tool paths. It's a relatively simple part, so it doesn't scare them away from the complexities of CNC, but they can generate the tool paths, run the simulation, verify their code, and then it's pretty much plug and play into the Siemens and the MCO. So I'm going to run that in the meantime. So, what we want to do, the goal of this class, the ultimate goal of this class, is to have students apply and train and understand manufacturing technologies. Once they get that, we can get them focused on the digital aspects of digital manufacturing. We can incorporate IoT devices, sensor packages, deployables, and at the very end, we're hoping and we're planning to develop and distribute this curriculum both to the rest of the school, to other schools, and perhaps maybe see it even used in industry. So at Georgia Tech, in the 2110 Creative Decisions and Design class, we're training the next generation of digital manufacturing leaders.